In section 12.4, we're going to talk about two more theorems. The first one involves tangent segments, and the second one involves two chords that intersect inside a circle. So the first type of problem involves tangent segments. So tangent segments are segments that are part of a tangent. And tangent segments have to have one of their endpoints be a point of tangency. So that would be the part of a tangent line if I extended this out so that it was a tangent line, because I'm really good at drawing straight lines. So if that was a tangent line and that would be the only place where that line touches the circle, so the R is the point of tangency. RS is a tangent segment. So one endpoint is the point of tangency, the only place where that tangent line would touch the circle, and S is just some point outside the circle. And segment ST is another tangent segment. T would be the only place where that line would touch the circle if I extended that out to be a line. And so what this says is that if you've got two segments and they have the same endpoint out here, point S, outside the circle, and they're both tangent segments. They both touch the circle at a point of tangency here, so that if you continued those out into a line, that would be the only place where the line would touch the circles. And they've got this common endpoint somewhere else here, so they make this lovely ice cream cone shape. Those two segments are congruent. So in symbol language, if segment SR and segment ST are tangent to circle P at points R and T, then segment SR is congruent to segment ST. So these right here mean those two pieces are the same length. The two sides of the cone, of the ice cream cone, are the same length. That's what this is saying. We could call it the ice cream cone theorem if we wanted to. It's saying the two pieces of the cone are equal to each other. So all you have to do on these problems is put a big fat equal sign between the two sides of the ice cream cone. So here, x plus 10 is equal to 17. If that side is 17 units long, well, that one also has to be 17 units long. The ice cream wouldn't stay in the cone if the two sides weren't the same length. So subtract 10 from both sides, you get x equals 7. Ta-da! All right, this one, if that piece is 4, that piece also has to be 4. They're the same length. So 6x minus 2 has to equal 4. Add 2, add 2. You get 6x equals 6. Divide both sides by 6. You get x equals 1. Ta-da! That's all this theorem's saying. Those two pieces are the same length. They're congruent. Congruent pieces, congruent pieces. Okay, the other theorem is a little harder to remember. This has to do with two chords that cross inside a circle. So you get this X shape inside a circle. And what it says is when you have that happen, the lengths of the pieces of one chord. So piece AF times FC. That piece times that piece. This one times that one. The two pieces of one chord. So AC is the whole chord, but it's been cut into two pieces. AF and FC are the two pieces. And if you take those two pieces and you multiply them together, AF times FC, that will equal the lengths of the two pieces of the other chord multiplied together. So you've got the whole chord right here. BF is one piece, FD is the other piece. So if you multiply BF times FD, that will equal AF times FC. I want to show you a visual form of this. So this is showing you the green piece, they're calling A, times the red piece, they're calling B, equals the turquoise piece, they're calling C, times the purple piece, they're calling D. And you can see they're plugging in numbers. So I've made it so the purple piece, this piece over here, is really small. Its length is only 3.8. And the turquoise piece right here is pretty long, it's 10.8. So those two pieces multiplied together are giving me 41.387. Now this chord, the green piece, the longer piece, is 9.098, and the red piece, the shorter piece, is 4.549, and you multiply those and you still get 41.387. And you can see that as I move these around, no matter what I do, the two pieces of one of them multiplied together are always equal to the two pieces of the other one multiplied together. No matter where they are in the circle, no matter where they cut each other, the two pieces of one multiplied together equal the two pieces of the other one multiplied together. So what this allows us to do is, if we know how long both pieces of one of these are and how long one piece of the other one is, we can find the length of the missing piece of one. So what you do is you multiply the two pieces of one of them together and set that equal to the two pieces of the other one multiplied together. So in this case, we have 4 times x equals 5 times 8 Well, 5 times 8 is 40. Divide by 4. And you get that x is 10. There's another one. So one of the chords is a segment RT. And its two pieces are the x and the 8. So we're going to multiply those together. 8 times x will equal 16 times 6, which I can write if I try really hard. 16 times 6 is 96. Divide both sides by 8. And you get that x is 12. So that segment right there, that piece, has length 12. Last one. Well, x is definitely the shortest of all those pieces. So let's try this. Those are the two pieces of one. 24x equals 12 times 17. 24x equals 204. Gives me x is 8.5. So those are the two theorems. Really fast and easy.